We look up at the sky, and without knowing why, we begin to ask questions. The sky feels quiet, but it is never still. Stars appear slowly, as if they have always been there, waiting for us to notice. We stand on the ground, thinking we are steady, thinking the world is fixed. But even now the earth is moving. It turns gently, without sound, without asking permission. The clouds drift, the air moves, time passes. We take a step forward, then another, and then we stop. Because moving is easy, understanding is not. We stay still, the universe does not. This is where curiosity begins, not with answers, but with wonder.
Imagine standing under a starlit sky, looking up at thousands of twinkling lights. Have you ever wondered, where did all this come from? How did the universe begin? Will it ever end? And perhaps most intriguingly, what is time itself? Stephen Hawking begins his masterpiece with a charming anecdote. A famous scientist once gave a public lecture on astronomy, explaining how Earth orbits the Sun and the Sun orbits the center of our galaxy. At the end, a little old lady stood up and said, "What you have told us is rubbish. The world is really a flat plate supported on the back of a giant tortoise." The scientist asked, "What is the tortoise standing on?" She replied triumphantly, "You're very clever, young man, but it's turtles all the way down." While we might smile at this story, it reveals something profound. Throughout history, humans have always sought to understand the universe. But only in the last century have we begun to find real answers. This is the story of that quest, from ancient philosophers to Einstein, from the Big Bang to black holes, from the tiniest particles to the entire cosmos. For most of human history, we believe the universe was eternal and unchanging. Aristotle thought Earth sat motionless at the center of everything. The stars, he believed, were fixed to a crystal sphere rotating around us. Then came the revolutionaries. In 1514, Copernicus dared to suggest that Earth wasn't the center, the sun was. The church was not pleased. When Galileo pointed his telescope at Jupiter in 1610 and discovered moons orbiting another planet, the old worldview began to crumble. Bruno was burned at the stake for suggesting the stars were distant suns with their own planets. But the most radical shift came from Isaac Newton in 1687. Newton didn't just describe how planets move. He discovered the laws that govern all motion. Drop an apple on Earth or orbit the moon around our planet. The same force, gravity, controls both. For the first time, we could predict the future of the universe using mathematics. Yet Newton's universe had a strange problem. If the universe was infinite and eternal, the night sky should blaze with infinite light. Why is it dark? And if gravity pulls everything together, why hasn't the universe collapsed into one massive lump? Newton couldn't answer these questions. Neither could anyone else for 200 years. Enter Albert Einstein, a young patent clerk with wild hair and wilder ideas. In 1905, Einstein published his special theory of relativity. He proved something shocking. Time is not absolute. A clock moving near light speed runs slower than a stationary clock. If you traveled on a spaceship at 99% light speed for what felt like 1 year, you'd return to find decades had passed on Earth. Time itself bends and stretches. But Einstein wasn't done. In 1915, he unveiled his general theory of relativity, and it was even more mind-bending. Einstein realized that gravity isn't a force pulling objects together. It's the warping of space and time itself. Imagine placing a bowling ball on a stretched rubber sheet. The ball creates a dip, and marbles rolled nearby curve toward it. That's gravity. Massive objects like stars and planets curve the fabric of space-time, and other objects follow those curves. This had stunning implications. If space can curve, then the universe itself must be either expanding or contracting. Einstein initially resisted this conclusion. He believed in a static, eternal universe. So he added a cosmological constant to his equations to hold everything in place. It was the biggest blunder of his career. In 1929, astronomer Edwin Hubble made a shocking discovery. Distant galaxies are rushing away from us, and the farther away they are, the faster they're moving. The universe is expanding. Space itself is stretching, carrying galaxies apart like raisins in rising bread dough. If the universe is expanding now, it must have been smaller in the past. Rewind far enough, and everything must have been compressed into an infinitely dense point. The universe had a beginning. Picture this. 13.8 billion years ago, there was no space, no time, nothing. Then, in an incomprehensibly violent instant, everything exploded into existence. The Big Bang wasn't an explosion in space. It was an explosion of space itself. In the first fraction of a second, the universe expanded from smaller than an atom to larger than a galaxy. In the first 3 minutes, as the universe cooled, the first particles formed: quarks, electrons, photons. Within minutes, protons and neutrons clumped together to form the nuclei of the lightest elements, hydrogen and helium. But here's the beautiful part. The universe wasn't perfectly smooth. Tiny quantum fluctuations, random ripples in density, meant some regions had slightly more matter than others. Gravity amplified these differences. Over millions of years, these denser regions pulled in more matter, forming the first stars, galaxies, and eventually planets. You, sitting here right now, are made of atoms forged in the hearts of dying stars. The iron in your blood, the calcium in your bones, the oxygen you breathe, all created in stellar furnaces billions of years ago. We are, quite literally, stardust contemplating the cosmos. But the Big Bang raised as many questions as it answered. What caused it? What came before? Why does the universe have the precise properties needed for stars, planets, and life to exist? To answer these questions, we need to journey into the strangest realm of physics, the quantum world. Look up at the night sky tonight. Those photons entering your eyes have traveled for years, decades, even millions of years to reach you. You're seeing the universe as it was in the past. And remember, the atoms in your body were forged in stars that died billions of years ago, scattered across space, and eventually coalesced into the planet you stand on. We are the universe become conscious, looking back at itself, asking, how did this all begin? Where is it all going? And perhaps most wonderfully, we're starting to find answers. As Hawking showed us, the story of the cosmos is the greatest detective story ever told, and we're all invited to help solve it.